Alright, so in this video I want to show you some of the special cases or weird examples, whatever you want to call them, for these compound inequalities. So it's an OR statement. We'll just add 5 to both sides and we'll get x is less than 7. And then over here we'll divide both sides by 4. We'll get x is less than 20 divided by 4 is 5. Alright, so what's strange about here is that they're both less thans. Alright, so we're gonna end up both of our arrows are gonna go in the same direction. Alright, so here's 0. Here can be 5, there can be 7. So the statement says this is true if it satisfies either one of these. So x can be less than 7 or x can be less than 5. So here's 5, open dot at 5, going to the left. And then here, less than 7, open dot at 7 and going to the right. But when this, left. But when this arrow goes to the left, it actually catches right up with this one. And so you don't have two directions. You just have all the numbers that are less than 7. Okay, so this actually does include 5 here. So you could do a little close dot there if you wanted to. All right, it does include 5 because 5 is less than 7. All right, it just doesn't include 7. All right, so for this one, divide by -3. All right, we're going to have to flip that sign because we divided by a negative. So x is less than, 9 divided by -3 is -3 again. All right, and then here we've got x divided by 4. So we're going to have to times both sides by 4 to get rid of that. All right, so timesing by 4 and dividing by 4 cancel. All right, and so you just get x is greater than, this will be -12. All right, let's see what our graphs look like here. And this is an OR statement again. All right, so here can be 0. Here's where our -3 can be. And -12 can be way over here. All right, so open dots at both of them. For this one, it says numbers that are less than -3. So that's going to be -2, -4, this direction, not -2, -4, -5, and this direction. And then here it's going to be greater than -12. So here, and you'd be going to the right forever. So you see here, it actually encompasses all of the numbers. All right, so the solution for this one would be all real numbers. So you could say all numbers. All right, so it even includes -3 because the -12 going this way passes through that -3. All right, one special case here for the and. Let's do this one first. That looks easier. Well, -9. And we'll just get x is less than 3 minus 9, -6. All right, on this side, we want all of our variables on one side. So we're going to -2x from both sides. All right, and we're going to want our regular numbers all on the other side. So we will add 4 to both sides. Ooh, windy. Let's see, on the left side, 9x minus 2x is 7x. The 4's can cancel. 3 plus 4 is 7. And then the 2x's can cancel. Divide both sides by 7. And we'll get x is greater than or equal to 1. All right, and this time it is an and statement. So we want to think of numbers that are greater than 1 and less than -6. This is not going to work out. All right, so here's 1. Now typically it'd be a closed dot here. And -6 over there. So the statement says we want numbers that are bigger than 1, so this way, and they also have to be less than -6. Well, there's no number that satisfies both of those. So the solution set for this one would be the empty set. Empty set, or you would say no solutions. All right, there is no solution for that inequality.